Okay, let's start. Let's get into the next presentation. I think you can see now my screen. Again, welcome to everyone from the English speaking countries. I have checked the attendees quickly. We have some from India. We have some participants from China, from the USA, England, and Europe, especially. They are all here. It's great to be online for you, to reach out to you. Normally, we meet at AMB show or MO show, which is also international. But it's pretty impressive that what, from our point of view, what is possible with a digital way. That's why also we have or DMAP race last year, and I'm looking forward now to talk with you about another specific topic connected to digital machining. I have prepared a speech for you which is related to the key goals of digital machining. It's digital sense for me. I connect the word digital with innovation, and yeah, machining means solution finding. And if we combine these two words, I think the speech, the topic of the speech fits pretty well into that expectation, into that motivation. We would like to show you now how we can reduce the costs in mass production, in machining mass production industry, by simple retrofit of spike monitoring systems. During the webinar, please mute your microphone, deactivate your webcam, but please be open to tell us your questions, put them into the chat, or call our engineers or write them in a mail. At the end of the meeting, I will have a Q&A session and where we can discuss the questions you have put in the chat during the speech. Just for information, the session will be recorded in order to be available as a download link afterwards for them who could not join now the live event. Which topics do we face or do we discuss in this speech? I have three main topics. First of all, I would like to introduce you our Spike philosophy. I would like to show you a quick video about our intelligent machine tool, how we make the machine tool more intelligent. I would like to show you an example how we think of the concept of big data and smart data, and I will close that topic with the benefits of smart monitoring systems. The second topic will be, how does Spike work? What's the functionality, and which machine integration opportunities do I have? Because monitoring is about smart sensors connected and integrated into the machine concept in mass production. The main topic of that speech will be four use cases where we have implemented Spike in serial production easily with different machine connection opportunities. Let's start with a concept, with our idea, with our understanding of an intelligent machine.
Pro-micron ist ein Unternehmen, was sich auf die Herstellung und Entwicklung von drahtlosen Sensorsystemen fokussiert hat, aber eben nicht nur dem System, sondern dem Algorithmus der Software, alles, was man damit machen kann, zum Beispiel eben auch in Maschinen. Wir sind derzeit 44 Mitarbeiter, davon 19 Ingenieure. Wir wachsen sowohl in der Produktion als auch bei den Ingenieuren, um das Potenzial, was wir sehen, zu heben. Wir haben in 2019 mit 247.000 Mitarbeitern in der Metallbearbeitung über 100 Milliarden Umsatz als Gesellschaft in Deutschland erwirtschaftet. Und wir halten es jetzt für ganz besonders wichtig, dass die Digitalisierungslösungen hier Fuß fassen, um diese Wettbewerbsfähigkeit, die wir bisher haben, auch weiterhin auszubauen. Und Spike ist unser Beitrag dazu.
Die Spindel ist Teil der Werkzeugmaschine, der eigentliche Antrieb. Wenn man die Kräfte in der Bearbeitung erfassen kann an der Spindel, Prozess analysieren, man kann den Werkzeugzustand analysieren, man kann enorm viel Informationen aus dem Prozess herausbekommen, um dann Prozesse effektiver zu steuern, effektiver zu fahren, um Fehler zu erkennen und so weiter. Und das ist das, was wir mit unserem Spike-System gemacht haben. Die Informationen werden sofort übermittelt und auch visualisiert. Er kann sehen, wenn das Werkzeug verschlissen ist oder eben, wenn es noch nicht verschlissen ist. Das heißt, er kann das Werkzeug so lange fahren, bis es eben wirklich seine Verschleißgrenze erreicht und nicht einfach wie bisher nach 1000 Teilen immer wechselt.
Bisher war es so, man hat mit der Werkzeugmaschine eine Bearbeitung durchgeführt und danach kam ein Qualitätssicherungsprozess. Das war ein zusätzlicher Schritt mit Logistik dazwischen, mit manuellen Schritten dazwischen. Das zu integrieren ermöglicht eine deutlich höhere Automation, ja, steigert die Effizienz. Das ist Hochtechnologie, die wir in Deutschland einsetzen.
Wir möchten mit Spike den Standard setzen in der digitalen Zerspannung,
weil wir die Überwachung von Zerspannprozessen in ein neues Level heben.
These are exactly the 2 points which are relevant from our point of view and which motivate us to implement solutions like Spike into production. Mr. Lisicki said said it in the video. The downstream quality inspection costs, they should be now in process, in order to reduce the costs. This is automation. This is innovation driven by companies like pro-micron. And the second point from our CTO, Dr. Wunderlich, is that with the features of Spike, we put monitoring we push that into a new level. And this is our goal. This is our motivation, and how we do that, I would like to explain you now more in detail. When you see this slide here, I have shown to you the value chain process in production today. And as you know, if you have a problem in production with every further step, which is after the process and where you don't identify the error, it will cost more and more and more. So at the end, you might have huge costs, which could have been detected in the process directly or which happened in the process. This is our main goal, to face these high quality costs and to reduce them. Let me explain our unique measuring concept with one example, and the example is in milling. Here you see the challenge and the problem in a milling operation. It's tool wear. It's one example of many others. I will explain later more. But the problem is the tool wears out. I can't see it in process. Suddenly, for example, there's also a cutting edge breakage and the surface quality will get worse. And this needs to be detected. So currently we do that with a downstream quality inspection. With Spike, we can now measure the forces directly in the process. We can visualize the forces on each cutting edge. And because of this innovation and this feature of Spike, we can detect machining errors in the process. But detection or visualization is not enough. We want to translate the big data which we have into smart data so we can reach automated reactions. In our smart software, it's called the Tool Control Center software, where we use the Spike KPIs. And if I have this smart algorithm, then I just need a function like an M command or a digital signal or something similar to the machine, to transfer that to the machine in order to get a reaction. Machine stop, change the tool, or activate the part sorter. This is our concept. By detecting the forces in the process, we can identify machining errors which lead to bad quality. And because we have this directly in the process, we don't need to do it afterwards with extra costs. Now I have a concrete question for you. Do you have similar problems like tool wear in your production? Or let me explain some other examples, some other challenges. In turning, we have to keep the tolerances, to have the right dimensions. It's a critical issue. In drilling, we face the problem of drill deflection or drill breakage. Do you have similar cases like this? Because if yes, you could tell us this in the chat, just with a thumb up. Do you have it or you don't have it? If you have it, it's exactly the right topic for you to discuss with us how to solve it with the Spike easy inline monitoring solution. So let's see in the chat if you have here a feedback. Is tool wear, for example, a problem in your production? Yes or no?
We've got a few yeses. Hopefully, a few more people can come in as well.
Okay, we have some yeses. That's what I didn't understand. That's what I was asking. Thank you. Okay, so then we are on the right track. So let's go more into detail how we could solve that problem. The cost overview here, the aspiration which we have is the cost reduction. We have here 4 key topics why we should do that and which benefits you gain of it. The main purpose of Spike, where we can reduce the cost, is by having the 100% in-process quality control, which I have mentioned. Here again, just 2 examples. The high volume production. I got the feedback from them. It's completely enough if they detect and sort out scrap parts automatically. This is the main purpose. This is a use case which we would like to solve in mass production, to detect scrap parts directly in the process and sort them out automatically. In high value, it's a little bit different. Here we have huge parts, long time machining processes. The benefit which we gain here is that we can locate and qualify and document process errors via a digital twin directly in the process. If we have this feature of inline process quality control, that means we can also use the tool to its full end of tool lifetime, because we always knew if we assure the right quality. One feature which we provide here is the force-based tool change. If we know also the how much load the tool can handle, we could even increase the productivity, again with assured quality, by, for example, optimizing the process parameters, putting more load on it, but reducing process time, or we use adaptive process control, or even by knowing, okay, my machine can handle much more load, I can push it a little bit more to gain and to increase the productivity. Another big benefit is, which is common now when we talk about digitalization. If you automate and connect the documentation, you can reduce paperwork and extra documentation efforts. You could, for example, if you have the data saved with Spike in an edge or in a network or in a cloud, you can directly go from the home office or from your computer, you can check the condition of your process, which saves you a lot of time. Another big point of automation is that machine tool builders can have a huge benefit, or system suppliers can have a huge benefit of solutions like Spike, because they could use these kind of data to implement it in their machine concept and provide the solution as a solution bringer to the market. Let's explain you how does Spike work and what are the opportunities to integrate it into your machine. With this slide, I would like to show you how simple the concept of Spike and digital machining is. We only need a hardware and a software to visualize and to detect the forces which are provided by the different sensors. For example, the Spike holder, the spike in spindle, or even machine data and external sensor data can be provided in the tool control center software. It's a smart system for monitoring, assistance, and data analysis. And sure, this can be integrated, this can be used for documentation into the cloud and visualization. Yeah. Which kind of sensor options do we have? Probably you know all the indirect measurement of the spindle load. These are powerful monitoring systems already placed in mass production. They monitor the torsion signal in production. They are fully integrated, but they also have limits, for example, in detecting small forces. This is one opportunity. And next to that, we have now with Spike the direct force measurement opportunity at the tool. We have two solutions, Spike Mobile as process-orientated retrofit solution with different sensitivities. Or if you buy a new machine or if you retrofit a complete new spindle, then you could have the in-spindle solution, for example, from DMG Mori and Grob, two machine tool builders which are already ready with a solution like this and provide you a machine integrated spike system. The benefit of these sensors are you can combine them. So if you have a spike and spindle machine and you have small process with small forces, you could also add the Spike Mobile. If you already have an existing spindle load system for mass production, but you cannot detect the deburring operation, for example, then just retrofit the Spike Mobile, combine it with the existing spindle load system, and here we face or we reach a cost-efficient retrofit solution. We can use Spike in milling, drilling, threading, reaming, turning, grinding, and freer stick welding. Which kind of opportunities do we have to integrate it? There are many. These are the main ones we are focusing at. We are focusing because they have different features for different benefits. The connection with analog or digital. This is, for example, a connection possibility to have a really quick communication between the external systems or between the Spike system and the machine. We use that, for example, for simple reactions. If you want to stop the machine or activate a part sorter, this connection is completely enough. By digital ins, you can stop the measurement automatically, and by digital output, you could give a signal to the machine, activate the part sorter, because this is a scrap part. If you need real-time connection in order to control the process or to share information in real time, then we focus on the Profibus connection. The disadvantage here is every machine is probably different, and you need individual protocols, and sometimes you even need to integrate the machine tool builder into the project, which is also another party, which we would like to reduce the effort. But if you want to have the quick real-time connection, we could also do Profibus. The third connection is the Ethernet connection. Here, lots of data can be transferred from the Spike system to the machine, or even machine data into the Spike system in order to create a digital twin, for example. And here, the lots of data is the benefit. To read the machine is the benefit. And with this connection, we are even possible to connect us or to connect the system into the network. It does not need to be real time in the beginning. It's just more for documentation and for in-process quality control, which we can provide here. I will use these three connections later on in the use cases and explain you which connection option did we use. Let's go directly into the use cases, into the main topic of that speech. I will start with the automotive example where we had a 100% scrap part detection while deburring. You see here the Stama machine park, the machine line. It's mass production, millions of parts per year, always the same process. The process we are talking about is a deburring process. Here in this case, the customer has used the high performance Heule tool. It's an expensive tool, but the process safety is high. And with this process, we were able to face and to solve specific challenges, because it might happen that there are sporadic mistakes and the process itself has very low forces. So the consequence is that we have, okay, the consequence is that the end customer needed to have 100% quality check downstream, because he was not able to identify the problem, a sporadic mistake in the process. So visual check downstream, which leads to high costs. By the way, later at 4:45 p.m., you will see that tool from Heule live in action with Spike, and it gives you another more live impression. How did we solve that problem? We used Spike. We used a Spike mobile tool holder. We have designed a specific customized holder for that application. We produced 300 of them because we implemented that in a project for 90 machines worldwide. And here we have used, we have found a solution, a perfect solution with the company Regafix. So high performance clamping system or tool holder performance in combination with Spike Mobile was the exact right solution to detect the forces of the deburring process, which happen here in production. And you see it's 1 Newton meter. It's really not a lot. But what was the monitoring point here? The customer just needed to see and to detect, did the deburring process happen, yes or no? So the monitoring software knew, which you can see in the right side, you see how the progress goes or how the forces are increasing. If it's too high in the beginning or if the forces is too low, we have 2 opportunities to send a signal from our software to the machine as an alert, and the part sorter will be activated automatically to say, this is the scrap part, put it away. You don't need 100% quality inspection anymore. Which connection did we use here? Since we were not using the tool control center software as monitoring solution, because we were using an existing monitoring solution from the spindle load, which was already on the machine. We did not want to get rid of that. We just we retrofitted the Spike features. We combined these 2 solutions, and we did this via the Profibus connection. The next example is a little bit more special because we have an online guest, Mr. Bauer. Thank you very much for joining that event, for being online. I hope we can hear you, we can see you. Yes, I can see you in the screen. Hello to Mr. Bauer, a process engineer for innovation at the company Alois Berger in Wertach, an automotive production company.
Hello, Mr. Riele. Hello, everybody. In this example, we manufacturing rings with 2 meters diameter on a milling turning center. The challenge here is tools were out, but forces are very low. 126 bores are made in 1 ring, during which we cannot measure it tools and change too early for safety. But the tool can suddenly break in the process. We know that if the tool with slightly scores will appear in the fit, we need now, this is the moment in the process, because it's clear that the tool could soon break.
Okay.
If the break happened, we would damage the component and have high follow-up costs. Does mean we need an in-process warning system.
Okay. Thank you very much for that explanation. I try to repeat that again. So it's a reaming operation. I think we see here a reaming tool, and I have put in a picture of a bad reaming operation where we see a little bit these cracks or these marks in the hole in the middle. That means you said the tool is wearing out. It's a specific, it's a normal topic in machining. But if the tool wear is too big, the tool might break, and then you will damage the high value part, and you have a scrap part and downstream costs. Yes. So for you in mass production, it would be beneficial to know, okay, when does these marks happen? When is the critical tool wear starting within the operation of 126 holes? I think we have here this picture again on the left side. We see here this huge ring. What's the diameter of the ring? What did you say? 2 meters?
2 meters, yes.
2 meters, okay. So we machine 126 operations. During these operations, the tool can wear out and suddenly break. This is something we need to know before the tool breaks. And as we can see here in the picture on the right, yeah, Mr. Bauer, which system are you using to detect these issues?
We use the Spike mobile system. We
Okay.
retrofit on the machine, and with the sensitive spike, even the forces of rubbing can be recorded. In the picture, we can see how a new tool looks like, a worn-out tool that produces growths.
Okay. So you just said the process, you selected Spike Mobile since the existing systems couldn't detect these forces. And we are here talking about 1.6 Newton meters. That's pretty low. As you can see in the picture, the red graph will be hit. It's a warning signal because the worn tool has too much force. So we just provide you now a signal like this traffic light red, yellow, green to say, now we have the operation. Please have a look at the operation before the tool breaks and damages the whole part.
Yes, of course.
And I'm showing here the solution you have picked. Why did you use the analog or the digital, the M command connection and not Ethernet or Profibus?
We are using the free M commands with a warning lamp via digital output signal, while the machine user must be not stay on the machine and start to record. The starting of records are in the machine with M commands.
You mentioned one. You mentioned one important point straight in the beginning. You have used the M commands which are already available on the machine. So you did not have a high effort to implement the Spike system. You are just taking these free M commands from the PLC, put in the 2 cables in order to activate, start, and stop the measurement. And if you have an M command in or digital in signal, you can even have a digital output with a traffic light. So you use the most simple machine connection because the purpose was just a warning. You don't need it to control the machine. There are no data stream, just warning. Very good.
Yes.
Yes, thank you very much for that reference, for that feedback. It was interesting to work out that case with you because we are happy that Spike could help you to avoid the scrap parts. Spike helps you to get more process safety, and even you can use now the tool to its end of tool lifetime because you know exactly when the tool reaches a wear limit, which makes bad quality. Thank you very much for joining that event.
Thank you.
Let's go into another example. Now we are talking about aerospace. And I told you before, in aerospace, you have long time machining operations. You have critical machining operations, which also have high quality and documentation requirements. Here I have this example. It's a blisk machining example This part we have machined yesterday on our DMG machine here in our tech center. And yeah, as this slide says, the challenge is process errors with low cutting forces, which need to be detected. Since we might have process errors, the consequence is we need a 100% quality check and 100% documentation is needed. Currently, the industry is telling us in mass production, they have the downstream check. They maybe need to rework the part, and there's no connected documentation. The solution with Spike looks different. Here, we record with a spike holder, with a sensitive spike holder. We can detect the forces in the machining operation. And since we have a smart machine connection via Ethernet, we can read out the machine data, the axis position of the machine. And with this function and with this, in this use case, we can provide you a digital twin. And here I have a little video which we have recorded yesterday. So a short video, since we don't have time to run the whole Blisk, but what you can see here is the machining operation itself. This is what the machinist sees, but at the same time, he gets now the digital twin with different colors. The colors represent different force levels, and because of the force level, we can have a direct link to the surface quality, too high, too much material, too low material, chattering, tool wear, and so on. So the documentation is done now digitally, and he can reduce his costs. I said we use the Ethernet connection. This is required because we wanted to stream the access data from the machine into our tool control center software in order to create with a new software tool, the spike map. Sure, we can also use the spike map for reactions, but as you know, in aerospace machine reactions, it's also pretty critical. That's why we focus on the quality, on the downstream quality inspection, which can be supported now with the digital twin of spike map. Let's get into the last example. Here we have a mechanical engineering example. It's not automotive, it's not aerospace, but we are talking here about machining. And the problem is in the application of a thread milling operation with an M2.5 millimeter tool. If the tool wears out and gets a specific tool wear level, the dimension and the radius of the thread is not in tolerance anymore. How to detect that in production? We don't have the time to stop after every cut. The customer where we are doing this, he said he is doing downstream checks, manual checks, and if he detects scrap parts, he needs to change the program manually and needs to implement the radius correction by himself. This means high quality and production costs, which we want to reduce. How the solution looks like, you will see now. We were using the combination of an existing spindle monitoring system toolscope with the feature of Spike Mobile to detect the fine bending moments in this operation. Here we are talking about 0.6 Newton meters in a new cut. You see the green graph here in the middle, and in the torsion and the axial force in the red and the blue graph, you cannot see this effect. And I have prepared this comparison between a new tool and a worn tool. This is exactly what our software and what our system needs to detect. When is the tool worn out with a critical tool wear so we can do a reaction? And since we have the direct reaction with the tool scope, with an existing system, where we use the Ethernet data stream as well, we can provide now the spike data, the bending, the fine patented bending moment can be visualized now in the tool scope, and the tool scope with its automation function can do an automatic radius correction. For this user case, I have now prepared you a video which explains and which visualizes that. I can show that now because the speech of toolscope, which has been done 1 hour before, has been also now presented. This is a new launch of an opportunity of a solution, a retrofit solution between two-scope in combination with Spike. So just to summarize that video again quickly, with Spike, they are able now to detect these fine forces in that threading operation. First of all, they can identify if the tool wear is too big and too big, so they can directly start the rework action automatically. And these are the 2 points which which make this complete process more productive and cost efficient. No manual rework anymore, and automated production, time reduction, and process safety. Here we see now 2 feedbacks from the market. Again, it's an aerospace example and an automotive example. Especially the automotive one is very interesting because it's already represents one specific monitoring example. Here, again, the finest bending moments have been detected in the line production with a power grip tool holder. And because of that, they are able to face the high and increasing quality requirements which they have in their surface treatment in the operation in 24/7. We are pleased, or we are thankful for also having the feedback of Bosch for our proactive and efficient project planning. I just want to tell you how we did it. We identified the need or the cost saving potential with them together. We have done a test trial with our Spike mobile holder in order to prove that it works out. And then we have designed a complete new tool holder with them. We managed the machine connection with the machine tool supplier. So they were very happy about that service, about that working together in this as a solution supplier. On the other side, we have now again the aerospace example. In aerospace, as we said, with a digital twin is used, or it can be used, we face this high demand level of quality insurance, which has high costs, high tool costs, high documentation and quality inspection costs. This is what we want to solve with real-time process monitoring, especially in the blisk machining. And here the first stages of using Spike have been already implemented. Now let's go back to the value chain, which I've shown you in the beginning, from pre-production to production to quality inspection. With Spike, we can now do the in-process quality control. We use Spike KPIs, we use the Spike map, or we just use warning functions to activate a part sorter. Basically, these are the three features you need to have in mind. This is what you need to ask us for. I would like to have the Spike map, or I would like to monitor via the Spike KPIs, or please support me just to identify scrap parts in process. And with these features, we face, or we our motivation and our aim is to reduce the quality inspection costs, which are still in high value in production. Now, we have 5 to 7 minutes left for questioning. I think I have heard some notes from my colleagues already. Are there some questions, or who wants to be first with a question he has noted during the speech? I'm free now to answer your questions.
Of course, so we had one a little bit earlier on from that was asking to confirm that how does Spike act as a tool to be able to enable the tool scope system to be more sensitive, and maybe just to expand a little bit about more on that from your discussions.
I would say yes in a first point, if it's related to the force level. But there are more features. For example, the Spike Polar, via the spindle load, you cannot detect, you cannot visualize the forces on each cutting edge. That's another benefit which comes from the Spike system, from measuring the bending moment, which can be added to the tool scope system or to spindle monitoring systems. Yeah? They are good for process monitoring and process safety. Did the process happen, yes or no, for the higher forces? And now with Spike, we have the opportunity to retrofit that solution to make it more sensitive, or to even get more information, more smart information into the program. And this option, if there is a combination, if the spindle monitoring system is already available, it's a very cost-efficient solution to just retrofit the sensory holder and not the complete monitoring system. So we use existing equipment to find a very cost-efficient solution. Okay, I hope I could answer that question. If there are more detailed questions, we could have a chat later, or send me an email and we will schedule a meeting.
Benjamin has a good question leading on from that, which is a three-parter, saying, how can we evaluate the potential and the cost savings from production? What are the next steps? And how much does the monitoring system cost?
Good questions, and questions we often face, because it shows that the customers have understood the need or the potential of using Spike as an innovative to make their production more cost efficient and the machine more smart. How do we go? First of all, we could have a chat, we could have an online meeting, so I can guide you, I can lead you a little bit how to, I can ask you the right questions, which you should do. But these questions are: what are the errors which make you which makes problems, or which cause, for example, machine downtime or scrap parts? Specify these errors, analyze, evaluate how much cost do you have with it, what's the conclusion of it, and then you can come to us, get in contact. We will discuss this feature, and we will evaluate based on our experience as well if it's worth to do it or not. And then the next step is completely clear. We take a smart spike holder, we go into your production with our diagnosis set, we identify, we record the error, and if we can detect it, we then can discuss what implementation is the one you really need, and then we can start a project. There was still, Benjamin, you had another question for how much is that system? This is a very good question. Depending on the benefit we can generate, we can evaluate with you together when we can amortize the investment. So I don't have a concrete price directly for you now, but our philosophy is to amortize the investment. It doesn't matter how it looks like. It needs to be done within 12 to 18 months. Otherwise, it's not worth, or the benefit we aim or we want to reach is too low. Alex, are there further questions?
Are there any more questions there?
It doesn't seem like that. That's why I would conclude with these simple points. Our goal is to give you a simple retrofit possible solution, which can be, or which, if it needs to be compatible with other systems, it can. It needs to be able to amortize within a specific time. It needs to be connected, and it needs to be digital. These are our goals, which we want to aim with Spike Easy Inline. Thank you very much for joining, and see you later in the chat or directly online in the other meetings. Bye-bye from Kaufbeuren, from our tech center. Thank you very much.